Hello, welcome back to Statistics and Mathematics YouTube channel. Today I'm going to discuss what is termed as covariance and correlation coefficients. That is what basically we are going to discuss for today, right? And then we are saying that for covariance is usually used to test for association between two random variables. So if you have two random variables and we want to see how they relate linearly with each other, we use what is termed as the covariance to do that. In mathematical sense, covariance of x and y is being expressed as expectation of s times y minus expectation of s times expectation of y. By note, if our x and y are independent with finite means, then the covariance x comma y is equal to what? 0, right? Once we see that if you have two random variables and they are independent with each other, the covariance that exists between them are equal to what? 0. So what is what? Correlation. Let x and y be a random variable with mean and then mean for x and y respectively, and variance for x and y respectively. Then the correlation coefficient, which is usually called the rho of x and y between the rho of x and y, is being expressed as covariance of x and y divided by what? The standard deviation of x times the standard deviation of y. So that is that on the correlation. But what you have to also notice that for correlation coefficient, they usually exist between -1 and 1 inclusive. So if you do any calculation for correlation coefficient and your result is more than 1, your result is more than -1, then that means that there is an error somewhere in your calculation that we have to check in order to get correct answers. Okay, yes. And then we have a question. It said let x and y be a discrete random variable with a mean equal to what? 46 divided by 21 and 33 divided by 21 respectively, with a joint probability by the joint, that is 1/21 bracket open s plus y for our x, which is equal to 1, 2, 3, and y, which is equal to 1, 2. So that is the observation for x and then y. You have been asked to calculate for what? The covariance. So the covariance of x and y is being expressed as expectation of s times y minus expectation of x times expectation of y. But within this particular question, our expectation of x is being given to us as 46 divided by 21, and expectation of y is being given as 31 divided by 21. Okay, yes. So all that we need to do is to calculate for what? The expectation of x times y, right? And for expectation of x times y, it means that we are going to sum on both x and y. And first we are summing on one y. That's the reason we are starting from y is equal to 1 to 2 and x is equal to 1 to 3 of what? The joint PDF times what? The function that we have here, s times y. So here we are going to have 1/21 s times 1 times x plus y. Okay, yes. And then first we are going to substitute in our x, and for the x we are going to get our x is equal to 1. As you can see here, s is equal to 2 and s is equal to 3. That is what we are going to get. Okay, yes. So when our x is equal to 1, we are going to put it here. So we are going to get here to be 1 times y. Obviously we are going to get y, and our x here to be 1 plus y. Okay, and then when our x is equal to 2, we are going to get 2y bracket open 2 plus y, plus when our x is equal to 3 to be what? 3y into bracket open 3 plus y. Okay, so that is what we are going to get for this expression. That means that we have put in our x values for the observation. That's the reason we are getting this observation here, right? So you are left with putting in y values. So here, if y is moving from 1 to 2, it means that we're having two observations. Y is equal to 2 and y is equal to 1. Okay, so y is equal to 1. We are getting 1 bracket open 1 plus 1. Okay, so 1 times 1 plus 1 will give us what? 2, as we have here. We are going to put in y is equal to 1 to this. We are going to get 6, as you can see here, to be 2 times 1, which will give us 2 bracket open 2 plus 1, which will give us 3. So when you multiply, we are going to get 6. And for this one too, you are going to get 3 brackets open of 1, of which you are going to get 3. You are going to, when you multiply it, you are going to get 12. Okay, yes, you are going to get 12. And then that is for the first y observation. For the second y observation, you are going to get y is equal to 2. Okay, so when you put 2 here, you are going to get 2 bracket open 2 plus 2, which will give us 2 times 3, of which you are going to get 6 here. Okay, and you are going to put 2 here, you are going to get 4. 2 plus 2 give us 4. Okay, so 4 times 4 give us 16. I want to put here, I'm going to get 6. 6 and then we are going to put 2, you are going to get 5. Okay, so 6 times 5 is going to give us 30. That's the reason why we had this observation here. So when you multiply everything and add everything, you are going to get 72 divided by 21 to be expectation of what? S times y. So for the covariance, you are going to get expectation of x y minus expectation of s times expectation of y. We are going to get 72 divided by 21 minus 46 divided by 21 times 33 divided by 21, of which you are going to get negative 0.0136 to be our answer. Okay, yes. So for the second question, we are saying that the PDF of two random variable is given by 8 times xy, where our limit will be 0 less than s less than y less than 1. Okay, find covariance of x and y, and then we should find the correlation coefficient of what? X and y. Okay, and this is a question that we have already solved in this series of video. Okay, yes, we had this joint probability distribution, and then we learn how to find the marginal for x and the marginal of y, right? And then we learn how to solve all this. So if you haven't watched that video, kindly go back and then watch, so that you understand what you are going to do for today. Okay, yes. So since you have been able to achieve the marginal for x and the marginal of y, I'm not going to repeat it again. All that you are going to do is to start solving. Okay, so the first question says we find the covariance of x comma y. Okay, so that one we are going to get expectation of x times y minus expectation of s times expectation of y. So expectation of x times y will give us integral moving from 0 to 1, and the integral moving from x to 1. Okay, so here we are integrating with respect to y, and after that we do that one with respect to x. Okay, so if you are integrating with respect to y first, it means that this is our y, and then our y is lying between what? X and then y. So our lower limit to be what? X, and our upper limit to be 1. Okay, that's the reason why we had x to 1. And then for the dx means that we are going to integrate over the whole limit. That one, it means we are going to start from 0 and we are going to end at 1. That's the reason why we are having this. Okay, yes. So this one, we are going to multiply what we have here, the function, the s times y, toward the PDF to be this s times y times 8 times x times y dy dx. And then when you do the multiplication, you are going to get 8 x raised to the power 2 times y raised to the power 2 dy dx. Okay, and then first we are integrating this one with respect to y. Okay, we are integrating this function with respect to y. So if you integrate it this with respect to y, you are going to get 8 x squared times y raised to the power 3 divided by 3. Okay, that's what you are going to get. And then you are going to put in the limits x and 1. And once you put in the limit x and y, you are going to get 8 divided by 3 s squared bracket will be 1 minus s raised to the power 3 dx. Okay, yeah, that is what we are going to have. So once we have this one, right, all that you have to do is also integrate this one with respect to what? X. Okay, we are going to integrate this one with respect to what? X. So when you do the integration on this one, that's what you are going to get, and then just put in the limit 0 and 1. We are getting our final answer to what? 4 over 9. So once you get 4 over 9, we have to also calculate for what? Expectation for x and then expectation for y. So for expectation of x, we already have our marginal of what? X. So this was what? Our marginal of what? X that we have here. Integrate it on 0 and 1. Okay, yes. So here we are going to integrate it on 0 and 1 of our marginal. So once you do the integration, you are going to get 4 s raised to the power 3 divided by 3 minus 4 s raised to the power 5 divided by 5. Okay, and just substituting in our limit, we are going to get 8 divided by 15. And we are going to do the integration for, we are going to do the expectation of what? Y2. And for expectation of y, we are having 4y. We are going to have 4y raised to the power 3. But we multiply y to it to get 4y raised to the power 4. Okay, and then we are going to get 4y raised to the power 5 divided by 5. And then we put in the limit and we get 4 over 5. So the covariance will be expectation of x, y times expectation of s times expectation of y. We are going to get 4 divided by 9 minus 8 divided by 15 times 4 divided by what? 15, to get 4 divided by 225. So this will be our covariance. Okay, so we are also to calculate for what? The correlation coefficient. And then we know that for correlation coefficient is just Correlation coefficient is just the covariance of x comma y divided by standard deviation of s times standard deviation of y. Okay, so here, before we get the standard deviation, you have to calculate for what our variance, right? And already we have expectation of x and we have expectation of y. For us to get the standard deviation of both x and then y, right, we have to get square root of what? The variance of what? X. And then for the y, we have to get square root of what? The variance of y. So that is what we need to get, right? And then we know that variance of x is equal to what? Expectation of s squared minus expectation of x all squared. And then variance of y is equal to expectation of y squared minus expectation of y all squared. That is what we have to find here, okay? So this is what we have to find. But already we have expectation of s and expectation of y. So for expectation of s squared, you are just to multiply s squared by this one, right? And once we do that one, we are going to get 4s cubed bracket open 1 minus s squared dx. And once we expand and then integrate, right, we are going to get this one and put in our limit 0 and y. We are going to get 1 over 3 as our answer, okay, for expectation of s squared. So what about expectation of y squared? So that one you are going to multiply 4 y squared by y squared to get 4y raised to the power 5 and integrate, right? Once we do the integration, we are going to get 4y raised to the power 6 divided by 6 on the limit of 0 and 1. Then we are going to get 4 divided by 6. Okay, once we cancel out, we are going to get 2 divided by 3, right, as our final answer. So for variance of x, we are going to get expectation of s squared minus expectation of x all squared to get 1 over 3 minus 8 divided by 15 all squared to get 11 over 225. And for variance of that one too, and for variance of y2, we are also going to get expectation of y squared minus expectation of y all squared, which is divided by 2 divided by 3 minus 4 divided by 5 all squared to get 2 divided by 75. Okay, so for this one, once we have this one, we know our covariance for x and y, and we know our variance for x and variance of y, right? So we are just going to put them into this formula, and once we do that, we're going to get our final answer to be 0.4925, and this one lies between -1 and 1. So we can say that this one is what? Concrete result for the correlation coefficient. So this is the end for our bivariate probability distributions. Okay, so if you get any notes on bivariate probability distribution, maybe I'll be solving more questions for you to get understanding on this particular topic. If you haven't subscribed, please kindly subscribe to Statistics and Mathematics YouTube channel, so that anytime I upload videos on probability theorems, you will really get some and then watch and be blessed. Have a lovely day. Bye.